So this is the 25th question of AMC 8 exam held in year 2022. So the question says, a cricket randomly hops between 4 leaves, on each turn hopping to one of the other 3 leaves with equal probability. After 4 hops, what is the probability that the cricket has returned to the leaf where it started? So let us say cricket is sitting here, cricket is starting from here. So this, I'll call this as the start leaf S. Okay. Now all the other leaves are not S for me because I have to come back to here. So I can either name them as A, B, C separately, but A, B, C will be same for me. So rather than naming them A, B, C, I will just name them not start, which is N. Okay. So all the other 3 leaves are not the starting leaves. So after 4 hops, I have to come back to the starting leaf. Okay, and I am starting with S. So now what the possibilities are, if I start with S, first hop I have to go to some other non-starting leaf, okay, which is N. So from S I will definitely go to N. Okay, now from N I have 2 options. Let's say from S I went here initially. So from N I have 2 options. Either I go to these 2 N's. So if I go to this will be N, this will be N. Okay, or I come back to S. So from N I have 2 options. Either I go to S or I go to some other N. Okay, so all the N's are equal to me for round. So from S I go to N and then S, or I go from S, N and N. Now in the first scenario, when I am at S here, so from S, whichever leaf I choose, again let's say I choose this leaf now, I will still be going to N. So from S the only option is to go to N. But from this N I have 2 options. Either I can go to S or I can go to N. Okay. So let's say I was here, then I went here and then I went here. Then this N, after this N I can either go back to S or go back to N, to another N. So from N I can either go to N or through NS. Okay. So how many hops I have taken? I have taken first hop, second hop and third hop. So 3 hops have been taken. Okay. Now for the final hop, if I am at N, again I can go to S or I can go to N. From this N, again I can go to S, I can go to N. But from this S, I can only go to N. Alright. So 4 hops have been done and either I am at S, N or N, depending on the scenario that I have chosen. Now I have to come back to the S. So I have to come back to S, that means only this case and this case which I have encircled, only those 2 cases are the valid cases. For all other cases I am going at N, which is not the starting point. So I will not think of the probability of that case. So I will first calculate the probability to reach this S through this path. So this path is S to N. S to N is, if I am S to go to N, it's a 100% probability. So 100% probability means 1. So 1 is the probability to reach from S to any of the N's. Because from S, the only jump I can make to is one of these 3 leaves which are N. So this is 1 probability. Now from N, let's say I was here. If I have to jump to S, there are 3 options. To jump back to S, there is only 1 option. So out of 3, 1 of the option is there. So this probability is 1 by 3. Now from S again, if I have to go to N, from S again if I go to N, let's say here or here or here, wherever I go, it will be N. So that will be 1 probability. And similarly from N to S again back, the probability will be 1 by 3. So probability of this path to reach S will be 1 into 1 by 3 into 1 into 1 by 3. That means 1 by 9. So 1 by 9 I will write it. So this is the probability of the first path, so that I start from S and after 4 hops I am at S. There is another path there. So either I take this path or this path. So the probability for the other path we will calculate. Total probability will then be 1 by 9 plus the probability of the second path. So again the second path you start with N, which is 1. Then from N again you reach N. Okay. So let's say I am at this N right now. I am at this N. So if I have to go, I have 3 options from this N. Either I go S or I go this N or this N. So if from N I have to reach N, I have 2 options, either this or this. So out of the 3 options, I can choose any of the 2 options. So the probability from reaching n from n will be 2 by 3. So this will be 2 by 3 here, this probability. Now I am at n again, and similarly from n I have to reach n again. That will be 2 by 3 probability again. Okay, and finally from n to reach s, the probability is 1 by 3, as we have seen earlier. So this other path, which is n s n n n s, probability of that will be 1 into 2 by 3 into 2 by 3 into 1 by 3. 1 into 2 by 3 into 2 by 3 into 1 by 3. That is 4 by 27. So this will be 1 by 9 plus 4 by 27. Okay. So a recap for you. So first we'll calculate 1 by 9 plus 4 by 27. 27 is the LCM. This will be 3 plus 4, which is 7. 7 by 27. So 7 by 27, answer option E is correct. So I'll do a quick recap. So the first path that was possible was S, N, S, N, S. This is one of the possible paths. Probability of that came out to be 1 by 9. The second path that was possible was S, N, 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 and then S. S, N, 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 and then S. So these are the only 2 possibilities that after 4 hops, you start with S and come back to S. And the probability of the second case was 4 by 27. Rest other cases, you were ending at N. Alright. So, and we don't want to end at N because we want to come back to the starting position. So only these 2 cases were possible. Probability of each of them were found separately and added to get the answer. Alright, that's how you solve this question.